Hello everybody, welcome to today's lesson. Today I will show you how to compute slope, aspect and hillshade using Google Earth Engine API. Before we go to the practical aspect, I would like to remind you to subscribe my YouTube channel, like, comment and share. Don't hesitate to do that. Let's get started. First of all, we need to have area of interest. So in this case, I would like to use the shapefile of North Oslo zone as my study area. So let's go to asset. From the asset, I have different shapefiles. From the shapefile, I would like to use North Oslo shapefile. So go to the right corner. Here is an arrow. This is import to script. Then click this, and directly this shapefile is imported to the script window. So the variable name is table, and I would like to rename as North Oslo. So the variable name is North Oslo, and the shapefile is listed here. The second step that I need to have is the digital elevation model with different spatial resolution. So to get the digital elevation model, go to search bar and write as SRTM. There are different data sources that provide digital elevation model with different spatial resolution. Here we have NASA SRTM digital elevation model with spatial resolution of 30 meters. Here we have with 250 meters. So we need to have NASA SRTM digital elevation model with 30 meters. So import this, double click or import this to the script. So variable name is image, and I would like to edit as digital elevation model DEM. After having area of interest and the digital elevation model raster data, I would like to clip out. The first step is clip the larger data set of digital elevation model by our study area or area of interest. So step 1, clip larger data set, in our case digital elevation model, by a shapefile or area of interest, the administrative boundary North Pole. To perform that, first we need to assign variable. So the variable name is digital elevation model of North Oslo. Then is equal to digital elevation model. The larger data set is digital elevation model. So I would like to copy this or write here as EM. And I would like to clip based on our area of interest or the administrative boundary of my study area. So dot clip. The shapefile is North Oslo. After having this, I would like to visualize the digital elevation model that I have clipped out based on my area of interest. So for the sake of visualization, first and foremost, write map dot center object North Oslo. So the zoom level is, let me make 9. So when I execute my code directly, it go to the northern part of Oslo, which is found in our artisanal state of Ethiopia. So let us visualize the clip data to perform that. This is the shapefile. This is the zoom level. So map dot add layer. Look, have a look this. Add map layer. The object name is the new clip digital elevation model. The visualization parameter is interesting. The color and the name of the layer should be stated. So in this case, the object is the new digital elevation model. Clip this or copy and paste. Then comma, the visualization parameter. You can use red color, the color palette, but if you are interested to use this, make it comma, and finally within quotation mark, write North Wallow digital elevation model. This is a layer name. When I executed this code within the layer name, this North Wallow digital elevation model will be available. So let's execute, run, or use your keyboard Control Enter. And finally, we'll get a clip digital elevation model of northern part of Wallo. Have a look. This is a digital elevation model that we have clipped out from the larger dataset, and this is in a grayscale, and I would like to have a color palette. So you can set a visualization parameter or simply go to the North Wallo digital elevation model with a little wheel and click here. Then, as you know, as you see here, there is a single band. So within a single band, you can set. Here the elevation is from negative to positive. So this is real data, and to customize or to have a real data, you can stretch the histogram equalization. So go to customize, and you can use stretch to sigma or to standard deviation, or you can use stretch 90%. So let me use this. Have a look. This is the minimum elevation of the desired elevation model of North Wallo zone, indicates that the lowest elevation is 1005 and the maximum elevation is 3,477 point something meters above sea level. So to have a color visualization, go to palette, click here palette, and click on add. Then let me have a green value for lower elevation or lower area. Make it okay. Add another category of yellow. This yellow indicates that the medium elevation. And finally, I would like to have a red color for the highest peaks in the steady areas. Then make it okay. And if you are interested to set a visualization parameter, this criteria as a visualization parameter, you can import, and directly we have a visualization parameter. So when we hit apply, the color is automatically changed to this color. This green area indicates that a lower area or lower elevation, the yellow one indicates that the medium elevation, and the red one indicates the highest elevation. To check whether the color is lower elevation or higher elevation, go to inspector and click within the green color. So the green color, this area indicates that the elevation is 1,467. Let me go to the yellow one, click on yellow color, and the yellow color indicates 2,207 meters, red one 3,457 meters above sea level. So you can inspect in such a fashion. Then you can also take this visualization parameter. You can copy this and replace within this parenthesis. So set it and run. You can simply get the color palette as well, because this is a visualization parameter and you can substitute here. Let's go to step 2. Step 2 is computing slope. First step to compute slope is we need to have the algorithm that helps us to compute slope. So go to document and refer slope. Here we have different algorithms. This algorithm helps us to compute slope. So click here and read further about e-terrain dot slope input. First and foremost, I would like to say something about slope. Slope is an inclination of an object, and it is computed by altitude difference over horizontal distance. So by considering altitude difference and horizontal distance, we can easily compute slope. So slope is generated from the digital elevation model with the help of this algorithm. Then let us take or let us copy this and assign variable. The variable name is slope. Slope is a variable name, and paste the algorithm or the function. Then the input data is the clipped digital elevation model, because I would like to compute the slope for the northern parts of Wollo. This is, and I would like to visualize the map. So you can copy this, or you can write map.add layer. I would like to copy the slope, or you can write here. Here's the visualization parameter. Instead of that, use this, and finally write the layer name as slope of North Wollo. Let us execute, run the variable or run the code. Finally, we will have two layers. The first is the clip digital elevation model, and the second one is a slope. This is a slope map of the northern Wollo area. I will show you how to reclassify slope within Google Earth Engine API in the upcoming videos, but for the sake of this exercise, I would like to show you a manual classification. So go to slope and click on a little wheel here. As you know, slope is always expressed in terms of degree and percentage, and slope value ranges from 0 to 90 degree. And I would like to classify this slope into 3. So go to color palette, then hit the R sign. So this is slope class 1. Let me have yellow, and the third class is red. If you have different slope classes, it may be 7, 5 based on file classification and other classification. I will show you how to reclassify in the upcoming videos, and you can set as a visualization parameter this category. It's imported and visualization parameter with param. The variable name, let's make this param slope. Then you can apply, and let's have a look. This is a slope map of the northern Wollo part. Close it. You can also inspect with the help of an inspector. You can click and you can, for instance, the green one is it have elevation of this much, and the slope is about 10.436. So you can compute in such a fashion. The third one is aspect. Let's compute aspect. Step 3, generate aspect. Aspect is simply a position of a slope, and the slope can be faced to the north, to the east, to west, or to south. So as far as aspect is concerned, it is position of slope. The slope position can be, let's see, east. East indicates that 90 degree. And south position in terms of bearing is 180 degree. And west indicates 270. and the final one is north is 0 or 360 degree. So this is the basic concept, and let us compute aspect, variable aspect, and go to the doc and explore how aspect is computed. So aspect, here is the terrain product and the terrain aspect. So we use this function as to generate aspect in a certain geographic area of our study. So click and explore. So terrain aspect is a function with the input of the digital elevation model that we have clipped from the larger data set. This function or algorithm helps to compute aspect in degree from the digital elevation model. Then let's paste the function, the terrain aspect, within this DAM North Wallo is the digital elevation model that we have used as a working parameter. Then let us use this instead of slope. I would like to use aspect, and this should be renamed as aspect. Let's execute or run, and finally we get the third parameter of the digital elevation model, that is aspect. This is aspect map of the my study area, and the slope is positioned within different direction. So go to layer and let us adjust the aspect. As you know, the aspect ranges from 0. 0 is north and 360 is north, because a circle has 360 degree, and the range always started from 0 and end with 360. So let's go to palette and let's classify into 4. You can further subclassify the aspect into different positions, because there is northeast, northeast, northwest, and the like. So there is angular bearing and compass pointers. So let me classify into 4. The first is, let me have this beautiful color. The second is let's use a green. The third, let's use yellow, and finally we have a red color. So it indicates that the aspect have a 4 category based on my classification criteria. You can import as this param. You can edit here this param aspect, then apply, and we will have a colored aspect map. So let me show you. We can explore both data. So you can inspect here. The pixel indicates that the point is found at this degree latitude and longitude, and the digital elevation model is North Wallo with an elevation of this much elevation. The slope is 17.66. Aspect is 164.94. This indicates that 164 indicates that southeast, because it is found between 90 degree and 180. So this indicates that the southeast facing slope. The final one is Hillshade. This is step 4. Step 4, Hillshade. Hillshade by definition is simply defined as the topographical arrangement of an area which is in respect to sunshine. So it shows that simply the topographic feature, whether it is mountainous or rugged topography. So hillshade is computed as follows. Let me assign variable is hillshade as equal to, let us write this hillshade to have the algorithm. This is a terrain product of hillshade. Then let me explore the function. The function indicates that Hillshade, we need to have input, the digital elevation model, the azimuth and elevation. The azimuth is sun angle, the elevation is the angle of the sun. So there is a default product. The illumination or the azimuth of degree of sun is 270 and the default value of elevation is 45 degrees. So let's copy this. It is essential. Then paste. Then what I'm going to do is I need to have a digital elevation model of North Wallow. Then the illumination is, we can use a default value or we can use your own bearing. So let's 270 within the angle of sun angle of 45 degrees. Finally, I need to have the visualization parameter like the rest parameters. So this is Hillshade, Hillshade, then let's to have Hillshade. Let's execute and finally let's explore the final result. This is my output. Finally, I do have 4 layers. So this is a Hillshade map. It is grayscale, black and white. So it is simply indicated that the topographic arrangement of an area. You can explore, go to Hillshade, and you can set the Hillshade value with different palettes. But Hillshade is always within the black and white. So let's inspect the data. For instance, if you are click within the pixel value of this, there is different data sets. Within this position, digital elevation model have elevation of 3,199. The slope is 0.42. This is a flat area, like a plateau. The aspect is 214. This indicates that the slope is facing towards southwest because it is found between 180 and 270. So within this direction, this is southwest. Especially it is southwest facing slope, and the Hillshade is 181. So this is a general statistics which is found within a pixel value of our result. This is all about today's lesson. If you have any question, let me know. Please don't hesitate, like, comment, and share. If you are a newcomer to my YouTube channel, don't hesitate to subscribe my YouTube channel. Have a nice day. In the upcoming video, we will see how to reclassify raster data by using Google Earth Engine. Have a good day.